Hello my dear pupils, welcome back in our second term in this year. We'll study together Unit 1 Lesson 1 which is the set of natural numbers. The set of natural numbers, actually we can use it in our daily life. For example, when we count anything, we can count anything around us. For example, people, money, chairs, students, anything around us, we have to use natural numbers in it. Natural numbers denoted by the capital letter N, because we have here in the word natural, the first letter is N. So natural numbers denoted by the letter N. Let's see a subset of the natural number, which is the set of counting numbers. Let's see this life example. A watermelon seller wanted to know how many melons he has, so he started counting. When he started counting, he says 1, 2, 3, and so on. The numbers 1, 2, 3, 4 are used to count things. So counting numbers, counting denoted by the letter C, because the first letter in counting is C. So C equals 1, 2, 3, 4, and so on. As we see here, this set is infinite set because it has no infinity, as we see here. Let's see some subsets of the set N. When I say N, you know that I'm talking about the set of natural numbers. The first set is the set of counting numbers. As you know, the set of counting numbers equals 1, 2, 3. We don't have 0 in the set of counting numbers. So C equals 1, 2, 3, 4, and so on. The set of even numbers, E. The set of even numbers E denoted by the letter E, because the word even starts with E. So E equals 0, 2, 4, 6, and so on. As we learned before, the even numbers is the numbers of table 2. And another subset is the set of odd numbers denoted by the letter O, because odd starts with O. So odd numbers, O equals 1, 3, 5, and so on. And the last subset is the set of prime numbers, B. The set of prime numbers B, we also know it from primary 4 and 5. B equals 2, 3, 5, 7, 11, 13, 17, 19, and so on. Let's see now some examples. The smallest natural number is, let's remember together, what is the set of natural numbers? The set of natural numbers equals 0, 1, 2, 3, and so on. So the smallest natural number is 0. The smallest counting numbers, when we count anything, we started to say, so count your fingers now with me. You say what? You say 1, 2, 3, and so on. So the smallest counting number is 1. The set of natural numbers less than or equal to 4. Less than or equal. When I see the word equal, I take 4 with me because it's equal to 4. So I take 4 with me and I say 3, 2, 1, and 0. The set of counting numbers less than 1. I don't have equal here, so I will not take 1 with me. What is the natural numbers? The counting numbers less than 1. No counting numbers less than 1. So the answer is 5. Let's see another type of questions. Choose the correct answer. What is the intersection between N and C? Actually, to solve this type of questions, we have to remember together in our draft what's N? N is the set of natural numbers. N equals 0, 1, 2, 3, and so on. What's C? C is the set of counting numbers. C equals 1, 2, 3, and so on. So N intersection C, the intersection means the common elements between N and C. What's the common elements between N and C? As we see, 1, 2, 3, and so on. So 1, 2, 3, 4, 5, and so on is actually Actually, it's C. So the intersection between N and C equals the set of counting numbers itself. Also because N here is the mother set of C. So C included inside N, so we say N intersection C equals C. Let's solve number 2. C difference O. C difference O. Let's write together. C equals 1, 2, 3, and so on. So C difference 0. The elements exists in C. Difference means the elements exists in C and not in 0. So the elements exists in C and not in 0 is C itself. The last one, N intersection O. N is the natural numbers. It's 0, 1, 2, 3, and so on. Intersection O 0. So what's the common between natural numbers and 0? The common is 0 itself. Let's remember that again. C subset of N, E subset of N, O subset of N, and B subset of N. C, E, O, B are all subsets of the set of natural number. Let's solve this type of questions. Complete even number intersection odd number. To solve this, we have to write in our draft for ourselves. What's the even numbers? The even numbers equals 0, 2, 4, and so on. What's the odd numbers? The odd numbers equals 1, 3, 5, and so on. What's the intersection between even numbers and odd numbers? What's the common between even numbers and odd numbers? Nothing, so we say here 5. The next question, N difference O. So N difference O, natural numbers equals 0, 1, 2, 3, and so on. And odd numbers equals 1, 3, 5, and so on. So N difference O means the elements that exist in N and not in O. What's the elements exist in N and not in O? The elements exist in N and not in O. 2, 0, 2, 4, 6, and so on. So these elements are the set of even numbers. So N difference O equals the set of even numbers. E intersection N, even number intersection natural numbers. Even numbers equals 0, 2, 4, and so on. Natural numbers equals 0, 1, 2, 3, and so on. What's the intersection between them? The common elements between them equals 0, 2, 4, and so on. So it's equal E. The last question, N difference E. Natural numbers, difference even numbers. What's the elements exist in natural numbers and not existing in even numbers? Yes, the elements are 1, 3, 5, 7. So it's a set of odd numbers. These are the answers as we mentioned. Okay, now I want you to open your school book, page 3, and solve these questions with me. In page 3 in your school book, let's solve this. Complete using belong, not belong, subset or not subset. 2 is, yes, 2 is belong to N. 3 over 4. 3 over 4 exists in N? No. So 3 over 4 does not belong to N. 55 and N. 55 is a set and the N is a set, so we use subset. Number G, 1 and 3 intersection 2 and 4. What is the intersection here? The intersection equals phi, and phi is subset of any set. Okay, the smallest natural number is 1. The smallest counting number is 0. The set of natural numbers less than 5. So we don't take 5 with us. So we say 4, 3, 2, 1, and 0. Natural numbers intersecting counting numbers. So natural numbers equals 0, 1, 2, and so on. Intersection counting numbers 1, 2, 3, and so on. So the intersection equals 1, 2, 3, and so on. It's the set of counting numbers itself. The next question, solve, put right or wrong. 7.2 belong to n? Of course not. It's not from the natural numbers. 0 subset of n? Yes. 0 union 1 and 2 and 3. 0 union 1 and 2 and 3 equals 0, 1 and 2 and 3. It's equal n. Is this all the natural numbers? Wrong, of course. He tries to confuse you because the natural numbers is an infinite set. It's equal 0, 1, 2, 3, 4, and so on. Okay, 0, 1, and 2, intersection 0, 5, and 10. The intersection here equals 0. Is 0 equals 5? Of course not. 0 is a set completely different from 5. The greatest natural number is milliard? Of course not, because the set of natural numbers is an infinite set. I want you now to solve page 3 from your booklet. Thank you, my dear pupils.